About that, I mean, see, this is not like you will find in any books. So you have
Okay.
to go through some concepts, and based on that concepts, you have to solve the questions. Like I will probably try to do with something like which will like I will upload videos on that,
Okay.
so you can go through it afterward.
Okay. Okay, but I am currently at this Somnath,
Yes,
so I can meet you during Diwali, sir.
I'm
Is it
in
possible?
Gandhinagar. I'm in Gandhinagar.
Okay, because during Diwali I will be traveling to Ahmedabad, so I
Yeah,
thought
if
that.
you are
Okay,
traveling to Ahmedabad, please visit. You're welcome.
okay, so thank you, sir.
So have you checked the videos on YouTube regarding this course? And if so,
Which course, sir?
same course, like we are solving the gate papers, question paper, like last 3 years, as well as questions
Okay,
from this NPTEL
okay.
assignments.
So I have watched a video that one person who has just given a geomatics paper, he has put the suggestion that you can go through NPTEL courses.
Yeah,
That's
so,
why I opted for it. There is no particular course regarding this geomatics.
okay, so basically this course is more or in line with that GIS Geomatic Engineering. Until now, like we have solved the last 3 years paper in this course.
Yes,
Like
sir. I am regular with
beginning.
your this YouTube classes.
Okay. So, like, I will upload once this is over, I will still upload on that same channel. So you can go through those contents and you will get a
Okay,
good idea about it. The
okay,
part on surveying and mathematics, basically. So I think we can start now with our today's session. Just give me a minute. I will share my screen. So are you guys able to see my screen?
Yeah.
yes, sir.
Okay, fine. So first of all, like we will solve some questions on the this week's NPTEL assignment, and then after we will start with some, if time permits, we will see some case studies of GIS. Just a minute. So yeah, so we'll start with the first question. So the first question is on buffer analysis, and all of you have used this thing like while the hands-on session we have used this tool when we did the one of the case study regarding the commercial, finding out the commercial zones to for residential property. It should be near to uh, restaurants, near to schools, near to roads. So that time we use this buffer tool. So when we create zones using buffers, so it is for which kind of feature? Point, line, polygon, and or all of the above.
Yeah, all of the above. Just saw the
Exactly.
answer.
Yeah, so it's all of the above. We can create it either around point, line, or polygon, and we can dissolve it so it will like merge if the two objects are nearby or two buffers which we are creating if they are nearby, it will merge them together. Then we have the second question is on which is the vector overlay type. So overlay type combining two different vector data sets. So from name only, it suggests like we can cancel out few options from the given four options. So first of all, tell me like how we will proceed, like which two options are wrong.
I think scan map over satellite image is not.
Exactly. And then the first one also, like here we are talking about vector overlay. So this term is vector, which means we do
Yeah,
not have to consider
no
image.
raster. Okay,
So
okay.
option A and option B are wrong. And then we talk about the C and D. So line in polygon. So you have line which is falling within the polygon, and polygon which is inside the another polygon, or two polygons are merging together. So option C and D are correct. And if you see in GIS, there are so many tools like us, this kind of vector overlays are there. So here, like, we will go with the first one. Let me just put my pointer on. So here you see the first overlay type here, where we have 2 points, 1 and 2, and two polygons are there, A and B. So here what we are doing is point on polygons. So, or point in polygons. So points which are within this polygon. So then if we will multiply this two, or if we took the overlay of this two, then what will happen, that it will add the information of the polygon inside the point data. So if we have the data regarding the schools, like we have digitized the data using GPS, and now we want to see like how many schools are there in one of the given districts, let's say in Ahmedabad or Gandhinagar or any districts. So this file we have as a district files. So it will like add the one in attribute table, it will add another field with the district of the that which contains that particular school. So this is kind of overlay analysis is known as a point in polygon. Then we have polygon which is falling on the points. So it's a reverse operation. So polygon in point. So what it will happen, like it will add the information of school inside the districts. So here we will be at the end we will have the shapefile of the district, and then whatever schools will be there, it will be included in the attribute table of that particular district shapefile. Now the third kind of operation in overlay is polygon on line. So we have one polygon and one line. If we combine these two, like find out the polygon which is falling on this line, so it like we will get this like 1A, so it will be like integrated together. Then we have polygon, so if two polygons are there, it will merge them. And here you can see one, and it is falling inside with the A and B both. So this will be like divided further into four different zones, 1A, 1B, 2A, 2B. Then we have lines on line, line on line, or line on polygon. So this is, sorry, line in line. So two lines are there, so it will give the intersection when these two lines are connecting with each other. So this is and this is line on line, not polygon. This operation is on line because we have two line data and intersecting and finding out the, and then we have line in polygon. So one line is there and it is falling inside the polygon. So we'll get the like integration, like if this intersection kind of thing. So a common point between these two. So these are the different overlay operations which are there in GIS. Then the third question is in GIS analysis of data or queries can be performed through process code. So if we do any kind of analysis in GIS, that analysis is known as which kind of analysis? So basically, if the first thing like
Spatial.
yeah, exactly. So the answer is spatial, that we are using the information of X and Y. That's why it's known as a spatial analysis. So we have the spatial information like slope, streams, which is all in like vector. One is in raster, another is land use, one is the soil data. So we'll integrate all the information which we have spatially, and then we will find out the some of the suitable sites for site suitability analysis, that it should have slope value less than this, it should near to be streams, it should have the land use of agriculture, or it should have black cotton soil. And if it is false, all four criteria, we will mark down those regions to find out the suitable area. Then the next one is which of the following is not a type of SQL statement. So SQL is structured query language which we use in GIS. So from the given four, which of the following is not a type of SQL statement?
DDL?
Yes, so data definition, no. Data selection, data manipulation, and data control. So data definition, it means we are giving data. So like there is options like make, create, and all. So it's like definition. So if you just go through this PPT, you will find under the definition you have the tools like create tables or create index. Then under the manipulation language, select, update, delete, or insert, and the control language you have grant, create user, and drop user. So So the correct option here is the data selection language, DSL. The next one is determination of change in land use and land cover requires filling the blank satellite images. So if we want to, if some particular area is there, so what do we need if we want to classify the image into different land use and land cover?
Temporal settle.
Yeah, so we need temporal satellite images, or we can also say it as multi-date. So images with having different dates. So image in 2010, image in 2011, like that. And if you want to do decadal analysis, we need one image in 2010, one image in 2020, like this. So it's known as multi-date and temporal. So now, like determination of best site using the criteria defined by user in a GIS is carried out through the process of. So I will just modify the
Type
question.
suit.
Yeah, site suitability analysis. And here is an example of it. So we want to locate a particular area of land for constructing a new school. So what we will analyze is we will analyze different land use, like whether the urban area is there or not, agriculture area, or whether the water is present nearby or not, or that kind of land use we will see. Then after, if it is near to urban area, we will give more importance to that particular pixels. Then elevation should be low. From elevation, we can derive the other aspects like slope aspects and all. So slope also should be less, because if we want to construct something, if slope is too much, we have to do more and more cutting and filling. So it should be like gentle slope for the construction purposes. Then we have to identify the current school locations, and we should identify a either like depends on our analysis, like we want to create a new school near to the schools which are there, or we want to create like the schools away from the 1 kilometer from the current school. So that kind of criteria we can specify. And then it should be recreational site, so schools should be near to the parks, or schools should be near to some other sport grounds. So this criteria is recreational site is there. So we can have different criterias, and then once we apply all the criteria, we can club them together and give the combined score, that if it is near to this, like we will give weightage like out of 100%, or like say out of 1, that this factor is represented, like you have weightage of zero point 0.2, then this has a weightage of 0.2 also. So then these are having the weightage of 0.4, and this is also having weightage of 0.2. So like that we will give a different weightage, and then we will calculate the score, like pixel value multiplied by 0.2 plus this pixel value multiplied by 0.2 plus this into 0.4, and then we will convert a final map which will give us the site suitability index, and then we'll see if the score is more, we'll consider those sites for the construction purposes. Then the next one is on ground penetrating radar. So this is like non-destructive technique to do the survey inside the ground without disturbing the soil, or without doing any kind of excavation. So which of the following statement is true about GPR? So it's kind of radar and the like signals. So
I think
how
the
the
first one and third one is correct.
yes. So from second and fourth one, like both are similar. Like they're having just a change of one word. So either one is right or one is wrong. So if we want to take signal from someone,
Second is correct. I think for
delta
second.
surface difference is related to the weak signal. So do you think that, see, if signal is going and then coming back, okay, so if the surface difference is like large, then what will happen? Like it will take time to come back, and we can identify the two different signals like properly, distinguishing between two different surfaces. However, if it is near, like surface difference is like less, then what will happen, that radar, like this radar will go and come back for both the surfaces, and because of that we will get the weak signal. Like here weak signal, it means it is not able to differentiate between those things. So see here, it is like source from where we are sending the signals. And if the difference between, let's say, two different surfaces is quite high, so what will happen, that signal will go. So first it will like collide with this particular surface, and then this. So once it will collide with this, it will come back, and now in the similar way it is going further. So if this difference between these two, if it is high, then the signal which we receiving, like the after the collision with the first surface and after the collision with the second surface, it will take time, which is, let's say, t. And if this surface like difference is less, then this time will get reduced, and if time will get reduced, we will not get proper signal. So higher the greater the surface difference, larger the amplitude, like we'll get good signal. So option A, C and D are correct here. So here you can see greater the surface difference, stronger the signal, and stronger signal has larger amplitude, and weak signal has small amplitude. So next one is the transportation route planning and traffic management can be done in GIS through which kind of analysis? So when we want to analyze the different networks such as traffic, transportation, so that analysis is known as a
Network
so
analysis.
yes, so it's known as a network analysis. Then intelligent transportation system is a new age system for air transportation. So it's false. Right now it's not. And a smart city connects human capital, social capital, and so this is like very subjective question, ICT infrastructure. So we'll not go into that. This is from
This had
previous.
actually come in the paper.
So these are from NPTEL previous year's
Achha.
assignments.
Okay, okay.
So now we will move towards the questions on GIS from GATE examination papers. So the first question here is, in GIS database, which type of attributes may be used to represent area? So attribute, like if we are creating a shape file, we can put different attributes. Let's say we can put the length, area, name of the lake, or the like change in the water area of that lake, or the temperature of that lake, or how many people are using, like coming to visit that lake. So these are the different attributes which we are putting in a shape file, and they are having some classification, that if the attribute has such kind of value, it is classified under one category. If it is a such kind of value, it is classified under Y category. So if we want to represent area, then which kind of attributes we should use? So anyone is familiar with the kind of attributes? Yes, no?
Types of attributes meaning integers, characters, strings, that way.
Exactly. So these are the normal attributes. Like time, it is kind of data type which we are using. But
Yeah.
here, what I'm specifying is, let's say if name is there, name of the lake, then it is like having obviously text data set. Okay, but what we are interested is whether this is like quantifiable or not. So it is, in that sense, we have divided the attributes into different classes, which is like this. So there are classes known as nominal classes. In nominal, like we have categories, but it has no order. Let's say urban area, or like forest area, water area. So it has different categories, but it has no kind of numerical integers associated with it, or no any order is that, like it is the first one, it is the second one, third one. So that kind of thing is not. So just categories are there. Then we have ordinal. Ordinal, like it's kind of order. So you can specify the order of the feature, that first, second, third, or like rank we can specify in terms of high, low, moderate, in such way, like basically using the orders or ranks. So that is known as ordinal attributes. Then we have interval. Interval lies like changing. So numerical values without a true zero. So let's say temperature of that lake or temperature of the city or wind speed of the city or the rainfall of the city. So all of them are having numerical value. So numerical values without a true zero, it is known as an interval, and then ratio. Here is without a true zero, it means, see, if you consider the area of the lake, it means area cannot be zero. Area, every time you will get some area. Okay. If you are specifying length, every time you will get some length. It is not like, can you define a feature with zero length or zero area in GIS?
Point.
Point, but then it will not convert like point do not have length and area parameter. Okay. So point information or the information which is like without zero information, without a true zero, then that is known as an interval, and then numerical value with a true zero and meaningful ratios. So they have true zeros. True zero, it means it cannot be like any kind of uh, we cannot represent line or polygons as a zero. So like like in GIS terms, it is considered as a true zero. And here like zero, it means temperature might be zero or like elevation can be zero. But here the word true zero is there, so it is something different than the just symbol zero. So here like ratio means we can quantify the different things, like if area is there, if we have two different features, then one feature is two times larger than the one feature. So that kind of thing is considered under ratio. Then we have booleans, which has the data type as a true, false, yes, no, 1, 0. Then we have text and string, which will be useful for name and other thing. And then we have dates as a temporal data sets. So here, if we want to represent different, let's say
Area comes
area,
under
so area comes under ratio. This is some of the specific terms which you should go through in any GIS books. You will also find that. Once my GIS is open, we will try to check that whether it has like representation of all those terms or not. Then the next one is what is the attribute uncertainty. So now you know what is attribute. So which of the following option is correct here?
C.
So error in source document due to cartographic bias. Anyone else?
I'm not sure.
B.
Error due to incorrect labeling and quantification of feature. Okay. Anyone else
No,
is there?
he said D actually. I think he said D, last one.
Okay. So, what did you told B or D? The last person who
I
was.
told B.
Okay, B. So D is the correct one here, because when we talk about attribute, it is related with the vector data. And you see this error due to imprecision in coordinate registration. So this is kind of geometric uncertainty, which we like solve using the georeferencing and other thing. Then this one also, error in the source document due to cartographic bias. So cartography, it means we have prepared map. We are using that map to georeference the image, and then we are digitizing the features from that. So if error is there in the source document, it will create a problem in georeferencing, which will ultimately cause the geometric uncertainty. That's why the option C is also wrong. And this attributes is related to the vector data. So from here also, like from option B, we can just suggest that error due to incorrect labeling, because if we have one lake and we have like by mistakenly we have correct like given that particular lake to another name. So or we have like the actual area is this much, but we have digitized some more area like this. So it has also errors due to the like in quantifying the area or length of the particular or parameter of that particular lake. Then we have error associated with the displacement of the object from its true location. So it's same related to the location and the displacement. So it is also comes under geometric uncertainty. So other three are more related to the geometry or the location uncertainty rather than as a attribute uncertainty. Is it clear?
Yeah, okay.
Okay. So then we have when we like in the last class in the interpolation, we like or whenever we did interpolation, we did two method. One is IDW and one we did it with tin interpolation. So when we generate the triangulation or tin triangular irregulator network, so it uses which kind of principle to generate the triangles?
Elonic.
Exactly. So the correct answer is B. And like there are no such name or method which is with Dalhousie, David, or Davenport. So this is like the straight away question. There is no method with these names. So there is no confusion on that. And what does this method specify is that if you have different points, so if you like make a circle using any 3 point like this, then it will not include any point inside it. So if you create a circle like this also, it will not include any point inside the circle. Okay, so similarly goes with this. So if you have something like this, so if we are like making this circle like this, then it will be considering like this. So it is not a denuded triangle. Then we have in GIS, reclassifying or reclassification is performed to. So basically, I will tell you what is reclassification. So if you have elevation data, then you will convert into two different zones, high elevation zone and low elevation zone. If elevation is greater than 2000, you will consider it as a high elevation zone. If it is less than 2000, you will consider it as a low elevation zone. So we have classified our data into two different classes, 1 and 0. And according to that, we will convert our raster data, which is like having elevation information, to the class information. So we are reclassifying our data. So we, in accordance with that, which is option is true.
B.
B.
Segment a data layer into multiple data layers. Classify a data layer using many attributes. I don't know. I'm not sure.
So just can you tell like why option A is not correct? You like confused between B and D, but I don't know why are you not confused between A also? Because what I told as example is, let's say if I have elevation data, if elevation data is less than 2000, I will give a one class. If it is greater than 2000, I will give it another class. So what actually I'm doing is I have range of elevation from let's say 0 to 5000. So what I'm telling, if it is less than 2000, give it as a one range. If it is greater than 2000, give it as a one range. So I am breaking down my entire range. So basically group ranges, which is from 0 to 2000 and then from 2000 to 5000 or whatever the maximum point I have. Group ranges of value into a single value within a data layer. So less than 2001, greater than 2000, let's say it will become like this. So this option is correct. Now we will think about the other three because that's what like reclassify tool do. Segment a data layer into multiple data layers. So here, I mean segment it like it will make the automatic segments, a data layer into multiple data layers. So when we use this reclassification tool, the output which you will get is this individual layer, not the multiple data layer. Segment data layer means it will consider like it will create a new file for less than 2000, let's say, which is like with the 1 and 0. Then for higher elevation it will make another file, so it will be two different files. But whatever this reclassification tool is there, it will create a individual file with the 0, 1 or more classes which you have specified. So because of that, like output is single layer rather than multiple layer. This option B is also wrong. then combine multiple data layers into single data layers. So we are not combining multiple data layer. We are just having one layer with continuous value that we are converting as a range. So that's why option C is wrong. And then classify a data layer using the many attributes. So if we have data layer, so using many attributes. So we are not using different attributes. We are using a classes or single values, like converting a range into different classes. So not attributes. We are having just one attribute only. Say let's say if we are considering slope, then if the value of slope is less than 10%, we will give as a gentle, like less than 5%, let's give it as a gentle value, and value is 1. Then if it is between 10 to like 5 to 10, like consider it as a moderate slope. Then if it is from 10 to 20, consider it as a high slope. If it is greater than 20, consider it as a high slope or a very, very high slope. So we are having 1, 2, 3, 4 value. But if you see, the attribute is individual only. It is not having multiple attribute. It is having just single attribute. Inside that we have classified different things like the different attributes. So which is known as which kind of attribute? It is considered as a nominal attribute, because we are having the different classes like high high slope, low slope, moderate slope. So having the attribute one only. That's why this option D is also wrong, and correct option is A. So just you just have to think about what this that tool do, and then analyze the all the four options. Now the next question is which vector data analysis tool combines the geometries and attributes from different layers?
Overlay.
Yeah, so this is directly what we see in the NPTEL assignments as well, this overlay. Then the GIS analyst has two raster dataset with same number of rows and column. And then what we are doing is we are taking an average of those two datasets, two raster datasets. So this operation is known as a which kind of operation?
Neighborhood.
Neighborhood. Okay. Anything else? Anyone? Can you recall, like, we discussed the classification, nearest neighbor, and k-means and all. So can anyone tell me what do you mean by neighborhood?
I think something like a convolution operation. You have like a cell,
See,
three
see,
by
see,
three cell or a
don't
family.
go into
Sorry.
that sense. Neighborhood, like just simple meaning of neighborhood. If it is nearby, I will assign that value. This simple. From the name only, it suggests neighborhood means it should be nearby. So neighborhood means what? If the pixel is like if I want to find out the data at this pixel, if I don't have data at this pixel, so what I will take, I will find out the nearest pixel or pixel which is in nearby region, and I will allocate the value of that into this pixel. So is this same type of operation which we are talking about here in this case? Are we doing something similar to that?
No.
No. So option B is wrong. Okay. Clear? Like how we deleted the neighborhood option. Because in that what we are doing, we are taking the nearest pixel and then we are assigning value. But here what we are doing is we are taking a mean at individual pixels. Okay, so we are doing the operation at individual pixels.
Then it'll be global
Global, what do you think is a global? So if I
because
tell,
it is
see,
different layers.
see here, this thing, when you talk about global level, like how the global temperature is increasing. This is just simple question which you should think. What is a global pattern of rainfall? What is a global poverty? Or what is a global usage of AI over the world? So what will it give as answer? It will generalize the picture. Is it true? Is it true or not? First of all, If I tell like how the people are using AI, like how the usage of AI or ChatGPT has increased in the last 10 years over the world. So we will get just one time series. Is it
Yeah.
okay? So that is considered as a global. We will get a just one time series plot, which is averaged over entire globe. That is known as a global value or global data. So there what we will get if we have entire different polygons or different like region, we will get just one value for that region. One value representing entire globe. So that's why option global is also wrong. Because in global what we will get is just one value for entire area. Now two options are remaining, local and zonal. Do you want to guess? Like 50-50 is over. So what do you think should be the correct answer here?
I'm scared I might get wrong again, and in 50-50 getting wrong is very embarrassing, and I don't want to guess.
So anyone else wants to try? See,
I think it is local.
yeah, it's local because we are doing it pixel wise. So local means you are doing it every pixel, and zonal means let's say if we have data of entire India and we are doing the district wise analysis or the state wise analysis. So we have divided the data of entire India into different zones of districts, sub districts, villages, or let's say states. And we are doing the analysis state wise. So that is considered as a zonal analysis. So where you have, what you have one shape file which is subdivided into multiple segments or different zones, and you are calculating the statistics over those zones, not at the pixel level. So that's why that analysis is referred as a zonal analysis. But what we are doing here is we are doing it every pixel level. So that is considered as a local level. And it will give us the idea of like what are the regions prone to heat stress, what are the regions which are having more rainfall, because we are doing like within the city also. So it will help us to capture the spatial variability well. Any doubt?
So
So,
bilinear interpolation and local is same thing.
Yes, we can think of because in that also we are doing it every pixels.
Okay, so zonal is a main name, or zonal has also another resampling technique. Like
No,
these are called resampling technique.
no, these are like PLC. It is a kind of operations, not resampling. The neighborhood I gave the suggestions like because it's like just it is not related to that. So it's not like every time it's a resampling. If we want to do, let's say, if we have data of mm, let's say well data we have like well depth, what is the water level in each and every depth, and we want to find out the let's say some any random point. So in that cases, we are having this kind of resampling or neighborhood operation. But here, the question which it is given, it's like kind of operation we are doing. So let's say you have a rainfall of June, July, August, and September, and you want to note down that what is the like total rainfall in the month like monsoon season of 2024. Then what you will do? You will do the sum of at every pixel. Where we are not doing any kind of resampling because both are having same raster. So here just we are doing the additions. But if both are have different, let's say, pixel size, then it will considered as a resampling problem as well. Here is just normal linear operation. But if the type of the data or the raster size of two these data sets are different or they have different rows and different columns, then it will be like different problem or of resampling. And first of all, we will make them like in similar row and similar column.
So, sir, we can say that in resampling, the two raster images have different pixel sizes. Huh?
Yes.
We can say that.
Yes. So when we do resampling, it should not be there that both should have similar coordinate system or like similar pixel size only. It will ask you the option that do you want to keep the coordinate system of the input data which you are specifying or not? Or do you want to use any other coordinate system while creating the new reclassify layer? So when you do some analysis in QGIS, it will ask you to specify the like size of the pixel also in the new layer.
Oh, okay. Thank you.
So basically, in resampling, what it will do is whatever the data point it has, it will create a like relationship using those data point, and then after it will apply into entire image. So it will like reclassify, like it will do the transformation over entire image. So we already discussed. Now the next question is you have to match the followings. Yeah. So this is related to the digitization part in QGIS. And some of the things we have like learned in the previous lectures as well. So can anyone wants to like connect anything with any like anything from column 1 to column 2?
Capital T is 1.
Duplicate entries. So point, line or boundary segments digitized twice. Okay.
Duplicate label.
T1. T1 will be. So yeah, we are getting our answer straight away. Option A. Correct. Good. No need to think about other. Okay, we'll
Yeah.
discuss other thing. So duplicate entry, it means it has digitized twice. Then duplicate labels. So labels, like why there is a different labels? Because two or more identification labels for same polygon. So if just one polygon is there, we are giving it as like we are like giving as a two different names. Let's say if some lake is there, one time we will give full name, one time we will give a short name or something like that. So duplication of labels. So there is a high chance that you might get duplication of labels as well as duplication of entities as well. Because what will happen in general when you do the digitization, you will digitize the first feature and you will give a name with, let's say, like name A, and then you will digitize the same. You don't know that you have already digitized this feature or not. You will digitize the same feature again, and then you will give it as a name A. So generally, like when we talk in real life, these two errors will happen simultaneously most of the times. Then we have artifacts of digitization. So it's like having issue with the digitization part. So either we are doing undershooting, overshooting, or wrong place node. So we have the correct area, but we are either underestimating it or overestimating it while doing the digitization. So this will go with this. Then we have missing labels. So while after creating the shape file, we haven't given any kind of label to the given class. So we have not defined any polygons, and we will not consider those kind of data. So I mean, if you see, if we have done one exercise where we used road network data from this OpenStreetMap. So there in type of the highway, there are some classes known as a unclassified. So there is no classification of highway which is suggesting by that particular attribute value. So this is like we have removed those data points, which is considered as a undefined polygons or as well sometimes. And then we have mislocated entries. So it's like related to the locations mostly. So it is at say, one place, but we have digitized at another place. Now we have given a network like this. If we remove the like make a topological map connecting the given nodes with each other, which of the following is true here? So first of all, we can count the nodes or vertices. So like first one is correct or not?
Yes, it is correct.
First one is correct. Now let's go to the second one. Age. So We'll like
Yeah, also correct.
we'll make like this topology. Like it will be straight lines. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is also right. And the closed polygon. So closed thing 1, 2, and 3. So this is also right.
Yeah.
Okay. So with A, B, and C.
ABC.
Now, which of the following types of tolerance uh, is used in GIS data when you do the editing? So this thing I don't know it's like covered it in the you are familiar with or not. But first we'll discuss that. What do you mean by those things? So there are different like if you have used any graphical softwares.
Snap
So
tolerance.
yeah, snap tolerance is more means what? Like if you have used AutoCAD or some any kind of tools in Canva or let's say PixArt or anything. So if you are like making some line like this, and when you are trying to connect it with the last point, it will show you like automatic cursor there that connect like it will which will automatically connect with the dot which is over here. So that is known as a snapping. And if you are having some error into that, that error is known as a slap tolerance. So let's say if very minute distance is kept in between these 2 points while making a shape file, it is considered as a snap tolerance. So snap tolerance is means what? That the distance at which if these 2 points are not connected with each other, it will automatically connect them as a together. So how much distance should be there between 2 points? If it is there, then we consider it as a individual geometry or closed geometry basically. Now, if this are not connected with each other, like if this polygon is not closed, and if you are running any kind of analysis in GIS, what it will give you as an error? So it will give you an error known as an invalid geometry. So whenever you are having this kind of faulty polygons, they will give you an error known as a invalid geometry. And then you can like remove like or modify that error using a tool which is specified with fixed geometry, which will do the same thing. It will just connect it with the polygon. So that is snap tolerance. Then the another one is a weed tolerance. So weed it means like in the region if multiple points are there or it will then it will remove the unnecessary vertices or like additional or unnecessary information for the simplification purpose. And then this grain tolerance. So like basically if we want to specify something like how much points are necessary, it will comes under width tolerance. And then is grain tolerance. So basically we first of all like we'll just discuss more about weight. So weight it means like if we given the tolerance of like this that consider this round, then there should be no vertices within this round. So if it will keep only one vertices or one node in that particular tolerance and it will remove everything else. Then we have grain tolerance. So grain tolerance is referred to the precision level to generate the details which you used to convert the data from raster to vector. So if you want to create a vector data, so here you can see two different lines. So one line with the very smooth curve and one line with the like very not so gentle, like it's not like it's very slopy. A lot of slopy feature is there. So that's where like this grain tolerance will come into picture. It will specify that how should like precisely conversion into raster to polygon. So precisely making this boundary with the curves. So by specifying more number of vertices. So how much vertices to keep so that it will consider the shape of this like curve and all. So that is comes under the grain tolerance. And when you talk about this polygon tolerance, so there is no such word in GIS related to the polygon tolerance. So this is like wrong answer here. Like that is not a tolerance part. This A, B, C are correct one. And then we have some other thing as well. So if this line is there here and one feature is there like which is hanging outside, then it is known as a dangling error. And this line connecting this with main line and the dangling point is known as a dangling arc, and this point is known as a dangling node. So it is just additional thing. So let's say here, let's say if we are having this kind of geometry, let's say this square I am making, but instead of I connecting here, I have like exceeded and then make the something like this. So this is known as a dangling. Like I have to go towards this point, but I went towards this point. So first of all, it is considered as an overshoot, and this thing is known as a dangling arc and dangling point. So with this, we'll go toward our next question, which is identify the type of digitizing error in the following figure. So the figure which is given here is like this. So this error is which kind of?
Dangling arc and yeah,
So see, think dangling arc means
overshoot.
dangling arc means what? That it has like completed the geometry over here and then it went forward. Okay, so you will get two different points if it is a case of dangling arc. Dangling arc. Here, what is happened? Like after finishing geometry, it is directly went from here to here. So it is kind of they have to stop it over here, but they went far. This is means it's kind of overshooting.
Overshoot.
So overshooting, it will like cross the particular point where they have to connect, as you can see here also. So if the point in this figure, black point, is if it is given here, or like it's overshooting only, but if 2 points are given, this along with the another one, then it is considered as a dangling arc. And undershoot if the point is given over here somewhere, and missing labels will not come into picture. So you can see the other thing also, and this thing we have discussed, like if space is there in between two polygons, that space is known as a silvers, and that is also our like classical error of GIS. And these are the other things which will happen by digitizing. You will have this kind of nodes, loops, or the switchbacks or bangles like that. Now we'll go to the next one. So which of the following is not a derivative of digital elevation models?
Emissivity.
Exactly. So if we have DEM data, we can generate slope, aspect, and contour, which we have seen in the previous classes on hands-on sessions. Emissivity we can't do. For that, we need additional parameters such as like vegetation, the NDVI, and the other indices related to the land surface temperature, brightness temperature, and all. So it will be helpful in considering the LST calculation. So we need brightness temperature from the satellite, then emissivity, and then there are formulas from which we will consider the lens surface temperature. Which of the following is a core vector GIS operation? Core vector operation.
Overlay.
Overlay, other three are related to the image. And can anyone tell me this is which kind of operations?
Raster.
Raster operations, but in that also, like we have learned about the image, digital image processing. So can you like classify the operations of all those three?
Spatial operations, meaning
Image enhancement, it was
Yes,
not right.
so it's image enhancement.
enhancement.
Yes. So the right answer is image enhancement. These three are. And for this question, the answer is overlay, which is a vector operation. And which of the following statement is or are correct? So we'll go one by one. First one is correct or not?
Correct.
Yes. So if we network, it means it's a vector data only. So that one is a correct.
Second one is also correct.
Second one is also correct.
C is not correct.
Not correct because they are in raster format.
D is correct.
Yeah, so it's pretty clear. So now the next one is in GIS, buffer is a zone with a specified width surrounding the spatial feature, as we have also seen in the first question of this class. Which of the following statement regarding the buffer is or are correct? So for point feature, buffer is an ellipse with minor and major axes as buffer distances. Is it true or
No,
false?
it's a circle, right?
Yeah, it's a circle. So that's why the first is incorrect. Next one is for a line feature, buffer is a band with a specified distance created around the line conforming to the line's curve.
Yeah, that is correct.
That is correct. Okay. Buffer zones are polylines.
I don't think so. No.
You just think if we buffer like point is there, if we are constructing a buffer around it, whether it's a polyline or something else.
It's a polygon. It's not
Yeah,
a
it's
polyline.
polygon, not a polyline. So that's why so it's a polygon. So the option C is incorrect. Then the next one is for a polygon feature, buffer is a belt of a specified distance from the edge of the polygon and conforming to its shape.
Yeah, that's correct.
That's correct. B and D. Now the next question is which of the following statement about the TIN data is or are correct or sorry incorrect. So this is how your TIN data will look like, which is generated using the Denouille triangles, which we learned in the previous just few questions. And here you can see TIN data for highly variable surface where topography is changing a lot. And then you see this data for planes, that how it will look like. So TIN contains irregularly spaced sample points. So is it true or false?
It's true.
So this is true because from this figure also it's like very visible that it has irregular points. Then the second one is triangulation is performed to form network of triangles.
True.
True. Yes. So now you see this option C and D both are similar, like kind of one will be correct, one will be right, and one will be wrong. Let's find it
D
out.
is true.
Which one?
D.
D is true. In the TIN model, the vertices represents the features such as peaks and depression. This is
Depression.
true because you can see this line if you take, it will represent the slope. Okay, not the peak and depression. So this lines will represent the slope, that how the elevation between the peaks and the valleys are changing. So this edges will represent slopes while the vertices will represent peaks and depressions. So option C is incorrect and other three are correct. Next one is which of the following statement is or are incorrect in the context of GIS?
A is incorrect.
A is incorrect.
Sorry. It's A is correct.
A is correct. Yes.
B is incorrect. C is correct. D is correct.
Okay. So can you tell what is the problem with B? Split overlays polygon and keeps all the areas in both layer. No, it's wrong.
It does not
Hmm.
overlay polygons.
Yes, it's just segment it out. Like then we have the next one. Which of the following is or are methods used for compact storage of raster data, raster GIS data? So these are kind of encoding. So basically, like I don't know if you're known about it
Quartering?
or so which one? Quad tree. what
chain
things we are
code,
using
raster, yeah, chain code and run length coding are used in
are there,
raster for,
and
yeah,
code
yeah.
tree are also useful. The decision tree is wrong here. So I mean,
Decision tree
those
is an
who
artificial
are
neural network.
not like familiar about this concept, so if you have some line like this, where which is in vector data, so this is we will convert it when we will convert, like when we store this data as a raster data, or let's say vector data, how we will store the data. So if it is a like a matrix, so we'll specify the values of this thing 1, 2, 3, or 5, or location or the address of this particular cells. So based on that, like how we are
Orientation.
specifying, yeah, how we are specifying the address of each and every location, that differentiate between chain, run length, and for tree. And there is no method such like decision tree. So we'll not go into that detail right now, because I don't think it will go inside this syllabus. So with this, we completed all the questions on GIS from Gates paper. Now I think what we can do is uh, we can just have a look around some of the one model question paper is there from 2022. So one model question paper is there. I mean, we can just have a look around or look on that particular paper. So what kind of questions we might expect, or like how much we have covered from this particular course of Advanced Geomatics Engineering. So we'll see these things. So few, like initially there are some questions on like statistics part, which is not like covered in this course. But yeah, we can expect, like we can solve these questions on electromagnetic spectrum of thermal infrared region, which is like being 3 to 14 micro, this option B. Then this is also the IFOV belongs to, like higher the IFOV, like how we are seeing the image. If like satellite is here, then IFOV is the angle which is made by
Spatial
this thing.
resolution.
So it will affect the spatial resolution. Then we have hyperspectral images have advantages of. So hyperspectral means it has more number of bands in the
Large number
image.
of
So
bands
large,
and
like from
wavelengths.
the like just if you know the meaning only, you can classify it, like find out the proper answer. Which of the following surveying principle is used by GNSS? So it's a known as a
Reliteration.
trilateration.
Reliteration.
Yes. Then among the below, which of the wavelength is used by GPS operation? So if you have gone through slides, like the
Second and third.
first, yeah, I think first and second is also, well, okay. I think if you in
The
GPS,
second and
see,
third.
first and second, I think it's like, we'll just check it out.
This 1575 is L1 frequency, and this
And
third one is I think L2 frequency.
first one is, I don't know, it's L1.
L1.
So this is like kind of numerical questions, like which if you know the exact numbers, so you can just identify. Then we have during the GPS observation, DOP value should be it should be minimum. So this is a conceptual question. So DOP value means like uh, how the satellite geometry is. If the satellites are near to each other, it will have more uncertainty, and in that case, DOP value will be very high. If it is distributed properly, then it has less DOP, and we get more amount of answer. In the process of synthetically subdividing the geographic domain into proximal region is known as a. So these are like few questions on GIS, so which we have not gone into. Then these are also like some kind of knowledge-based questions. So line representing equal elevation are known as the contour lines. Line representing equal let's say gravity is known as a geoid. So similar to that, there are so many words related to the line representing equal different things. So this isogonic is used for magnetic declination. So you have to find out this is for, I think, magnetic deep. Then ordinal variables have. So ordinal variables have. This is like we have just solved today. What will be the answer? Ordinal variables. So in the starting only we have seen the different variables. So you can see the ordinal is a categories with the specific orders or rank.
Order.
So here the discrete classes but inherent order or sequence. Okay. Then given a histogram of a grayscale image, find the wrong statement. The statistics of the image can be computed from the histogram. That is true. The histogram conveys the information about sharpness of edges in the images. The probability of finding the
False.
correct level at every pixel can be estimated. The probability we can find out using histogram. Then the entropy of the image can be estimated from the image. I think
So,
see the option A and B are correct.
so
Sharpness,
what's entropy?
sharpness. I think we don't do that because for finding out the sharpness, what we do is we apply the filters on the image and then like different filters. So for that we need the spatial representation also. Entropy is a statistical concept.
Okay.
So like what we can do is we can use ChatGPT right now to check that what might be the correct answer.
C is wrong. C is wrong.
See,
C is the
mostly
option.
C is wrong. Considering the sharpness,
I
I
think only
think
C is wrong.
we'll check it out. So yeah, C is wrong.
Oh
Yes.
no.
What? What? Oh no.
What are you doing?
So this is like how you can learn different concepts. I mean, like if you provide all the questions on ChatGPT, it will give you the correct explanation as well. Exams, you don't have that flexibility, but yeah, for learning and if you don't know anything, it's a good tool and you can validate your answer with the books. So we know something, if you are 50-50 between, we can check it out. So that's one way you can go around it. And like most of the quizzes, like what I did is like I have done the like all the 3 questions papers from gate examination. Most of the conceptual questions, ChatGPT is able to clear like even in the numerical questions, it is able to give the correct answers of it, like whatever we discussed in the previous classes as well. Then we are having the which of the following resampling algorithm retains the raw pixel values. So this is like I think we have solved this question in the class as well. So a correct answer here will be the nearest neighbor because if something is there only, so nearest point will be like distance will be 0 and then it will assign the same value in that pixel. So there is no change when we are using nearest neighbor algorithm. Then supervised classification methods in remote sensing would essentially require
Prior knowledge of ground
we
features.
should know what is there on ground, then we can use that information to classify our image. Then there are few questions from survey part, so we will not go into that. Then the next one is
These are looking quite
yes.
tough, I think.
So I think it's tough, but if you know the concepts, you can go through. Like we can solve it. But I mean, it is out of this concept, like this basically course, so we'll not go into that right now.
I'm thinking that I should go with the photogrammetry and remote sensing one.
So this is the common section. Like everyone has to attend this question, like questions. So this what you are seeing right now, it's like compulsory part for both parts. And this is quite like resembling with our syllabus, what we learned in this course as well. Uh, Visual interpretation of images depends upon
Quality of the image.
quality.
Multiple answers.
Yeah, it's like having multiple answers. Like most, like here the most probable one which I should consider is experience of interpreter compared to the quality also. Because is like if quality is not that good, but the person who is analyzing the image, if it is like because it's a visual image interpretation, it is not into like automatic classification or automatic identification of different objects. That's why if it is something automatic, this quality will matter. But here I think in visual interpretation, the experience will matter a lot rather than other factors. Supervised classification methods in remote sensing would essentially require prior knowledge of ground
Prior
truth. So
knowledge
I
of
think it's a
ground.
repetitive question. So calculate the range. Okay, this is go. What are the errors that cannot be eliminated using the differential GNSS technique? Differential GNSS, if I want to repeat. So what we learned during that time is that if error is same between two observations, that we can remove using the differential GPS. So if we have fixed the let's say receiver at two locations, the error which is there in the atmosphere, which is related to the ionosphere and ephemeris, like that we can like troposphere also we can resolve easily. Even ephemeris error, which is error in the satellite orbits, because it is same for every receiver point. But multipath error depends on the nearby feature. So if you have kept the let's say receiver in such area where buildings are there or where the nothing is there, error will be different. We cannot eliminate those errors. So I think multipath error we cannot solve using the GNSS technique. Given a correlation matrix and covariance matrix for M cross N cross K image, where K means the dimensionality or different bands in the image, which statement is true? Both correlation matrix and covariance matrix are always full rank matrix. In the general case, correlation and covariance both can be zero. If both data vectors are zero, means covariance matrix and correlation matrix are identical, and then the diagonal element of the covariance matrix indicates autocorrelation. So that is true. I like diagonal. What do you think? Like it will represent the variance, and if we take the under root of it, we will get the standard deviations.
I think B is correct.
Like answers are not given like for this question paper, so we will give this to ChatGPT and we'll check it out, because answer key is not given for this particular model paper.
I
So we'll
think
check it.
B.
So incorrect statements is option A. So both correlation matrix and covariance matrix are always full rank matrix. So why it is incorrect? Can anyone tell? Like, do you know what is mean by here? It's always full rank matrix. So full rank means if two bands are like having good correlation, or we can represent one or two bands using the linear combination of another band, then it will become like we can nullify the effect of one band. And that's why like if you have M cross K, like rank, it's not full rank, it is reduced from the full rank. And because of that, I think option A is incorrect, because every time it will not break if two bands are similar response in two bands for let's say one particular area or patch of the image. It might be possible that it should not have full rank. I'll see the other option why the others are correct. So if the data vectors are non-zero mean, and the other thing, if the data vectors are zero means mean vectors, covariance matrix and correlation matrix are identical, because if it is zero, then it will not matter, like it will become the identical only covariance and correlation, because if variance is zero, the correlation will also become zero. In the general case, correlation and covariance both can be zero, so might be possible, because if covariance is zero, correlation will automatically become zero. Then unsupervised algorithm clusters iterative process. Like we have ISO data, iterative self-organizing clusters. So it's iterative thing. Then image transformation techniques generates a new image, modify the original data sets, does not generate a new image, or none of are correct. None are correct.
It transforms the original, so we can say modify the original data set.
So modified the original data sets. So basically, we are doing transformation from one to another. And if you see, like if you see in terms of GIS, so when we perform this operation, let's say when we do any kind of operations, what it will give us output. Okay, so this option should also be correct. I mean, generate a new image, because once we do the like
No,
transformation,
maybe
it
if
will
they are
generate a new
talking
image.
about
But
creative,
if they are talking about entire new image, then it's not a correct one. But if we see as a variable which stores the image, then it's true. So this kind of ambiguity comes while you are writing an exam. What we are doing right now, solving impromptu questions. Then Boolean operators used in GIS overlay analysis use
and nor.
hmm, and or nor. Like everything, like if this and this is true, then it will get one. Then the next one is UAV collects data by flying at relatively lower altitude using a combination of cameras operating in a different wavelength regions. Uses a laser beam, uses only black and white camera. So this is not true. I mean, like it might be at different altitude. It depends on what kind of UAV you are using. Then using a combination of cameras operating in the different wavelength region. So this might be true because like we have normal multispectral camera fixed with the UAV, or hyperspectral camera or thermal camera. So it might have different cameras depending on which kind of drones or UAV systems we are using. So when we talk about data, so it will collect the data from those only, like using the combination of cameras which are mounted in the UAV. Then the trigonometric. So these are the further questions from surveying. Then aerial photographs, the height displacement is so these things we have learned when we discussed about the relief. So this is the nadir, and then we have some tower or something over here at this particular location, and what we see in images as a relief distance of that particular tower, and that is like directly proportional to. So this thing like we have already solved multiple times. We'll not go into that. So here in general, if you want to see, you just have to use the formula of relief, and that's then the state the it is proportional to which. I will just look into things which we did. So I think directionally, yeah. So this same question, similar questions we already saw on here. This is related to the scale, and so this is the formula of relief displacement. So dH by R. So R is the radial distance. So if we see this thing, directly proportional to the flying height of the aircraft. So H is directly proportional. Then the radial height displacement is radial from the principal point. So this is the principal point. So it is in radial direction. So that is also true. This is maximum along the line joining the corner fiducial mark and the principal point, and then is inversely proportional to the height of the object. So height of the object is wrong. So this will be the relief displacement of the tower is 2.1, and the so if we just divide, so this is the relief displacement is D. So we can specify H here. It will go in the bottom. Just specify. relief displacement D will become HR by small h. So here if we talk about the parameters, this is relief displacement, then this h is the height of the object, then the r is the radial distance, and the h is the like how what is our flying height from the base point or mean sea level. So from this, like we can see that it is directly inversely proportional to the flying height, directly proportional to the height of the object. Higher the height, higher the relief you will get, and then higher the distance you will get more relief. GPS Nowstars system is developed by USA. The most commonly used method to minimize the effect of errors in observation, weighted mean, say, but it's not part of survey. In GIS, the removal of noise is carried out using the, this is also, we haven't touched upon this. So then the latest Landsat mission collects the data in, so this we consider like 11 or 12 bands Landsat 8 and 9. So you can always go through the catalog of all those uh, Landsat missions, like before going to exams, always go through those data sets of currently uh, like available satellites, which are Landsat Night, Sentinel. Then the, if you say talk about the ISRO, then we have RISAT. Then the further combined mission, let's say NISAR and the other products as well. So you should always go through those. So, so you can see it has around 11 to 12 bands it has. Exactly, we'll see. So in the, I think Landsat 8, we have coastal aerosol, then blue, red, green, near infrared, shortwave infrared, then two, like one thermal band is there. So, know what is happening with my internet. So it has 11 bands. So as I told, coastal aerosol, visible blue, green, red, then infrared, short two bands from shortwave infrared, one from panchromatic band, and then one for detect clouds, which is Cirrus band, and then two thermal infrared bands. And then Indian GPS system is can anyone tell which one is correct?
Gagan,
Uh, is it true? Gagan is what?
Nisar,
it's
no?
augmentation system. Augmentation system.
Gagan is
Then
kind of augmentation system rather than GPS system. In GPS, we talk about we have Navig or other name is IRNSS.
Yeah.
So navigation with Indian constellation or Indian regional navigation satellite system IRNSS. So here none of are correct. Then these are the questions from survey, and this is like we have discussed like optimal flight planning for photogrammetric survey. How much overlap should be considered in the longitudinal and side lab? So you can go through those numbers. Then digital elevation models can be generated using the photography technique from the following data. So we have, like in second week only, we have used the stereo images, or like if we have two images taken from different angles, we can generate the digital elevation model from that. And this is also true if we have the ground data from collected using GPS, then also we can convert the DEM. So it's like different answers, all of the above. In aerial photograph, area having an average elevation of 1,500 meters is taken at a scale of 1,000 1 to 5,000. The focal length of camera is 15 centimeter and the altitude of the height. So this is like very classic questions which we solved in the first and second week of this particular course. So you can go through the PPTs which I uploaded here in this class. So we have the scale is equal to focal length divided by h minus average height. So use this formula and calculate the this particular question. Then this is based on like theoretical thing. So which of the following term is not used in the aerial photogrammetry. So it's like back sighting is mostly used in the land surveying. So this is not correct. Parallax and fluvial marks are there. So this we use 1 and 2. So I think then slewing is there. So I think here option 3 is not correct one. Okay, which of the following is not used in? So obviously this third one is not correct. This first and second and third, I think we are fourth one we are using. Survey where shape of the earth is considered, that it is known as a geodetic survey. So like this questions which you are seeing right now, this is from the surveying portion. The above portion, like based on common GPS, GIS, surveying, and remote sensing knowledge are like common for both the like who are appearing for survey and who are appearing for image processing part. These are like totally based on the survey. So the plan of a map was photocopied at a reduced site. So this is the similar questions like how it is going to reduce. So this is also we have solved in our classes. The same questions, these values are changed. Even we can find out like it's a same question in the week 2. So plotting accuracy. So this is like similar to what we did. So the same kind of questions we have solved. So you can just go through the questions which we have solved previously in this course, and you will find like very good like answers from those only. So same questions like how. Then we have which of the following statement is false. So this is based on the surveying part, based on labeling part. So not going to that. This is also we have solved. This is also we have learned through the like in-depth classification of Survey of India's map through million sheets to the dividing that million sheet into 4x4 zones, and then further division of it into different zones like 16 zones. It will become every 4x4 grid will further divide it into further four parts like this, so it will become a lot, and then how it will change the scale. So we have learned all those things in the week 2 or 3. Then these are the questions on surveying. Then this is like, I don't know, this is model paper, they have integrated it over here, but this is like how we'll get the response of this convolution. So this we learned it while using the filtering. Then this is also from the similar thing which we used in this first few weeks of this course, where like questions related to the aerial photogrammetry. So this is same formulas you have to use. Scale is equal to, and then radial distance from top and bottom of the tower is principal points are like. So this is same questions we have solved, which they uses the concept of relief. Then electric poles appear two successive overlapped photographs the focal length. So this is also similar questions, like it is on the parallax. Then which of the following geometries errors are accounted by the first order polynomial affine transformation. So in first order we'll just do the linear operations. So we'll just consider scale rotation and translation, not the shear. Then we have the PC and other thing. Then so this also we reduce the dimensionality in the data. Then we have this given matrix, and we have to find out we have to apply the mean fixed pixel of 3 by 3, and we have to find out the value at the center of the pixel. So you just apply the mean factorial 1 like take the average of all those points and do the average and find out the values. So just take all the values divided by 9. Given the below raster map of wind speed, with 1 being the low speed and the 3 being the moderate speed. The direction of, so you convert this data into low like ordinal attributes with the ranks, and find out this is low speed and wind speed, so how it is moving. So based on the convergence analysis you have to do this. Then the process of digitization, converting an analog signal or the image into digital forms, involves the
Sampling,
Digitizing,
quantization, and
yes,
coding.
sampling, quantization, and coding. Which of the following operation is not linear? So this also we discussed, but here options were different for our cases. So I think quantization is not a linear process. It's kind of
Yeah, correct. Quantization.
hmm. Then the image of M cross N converted with this filter of K cross L result into the output image of. So basically, whatever the image is there, yeah. So it will be like what? Are you saying anything?
Sorry, did I say something wrong? I'll check. I'll
No,
check.
no. So you just go through it like we are not solving each and everything, but like these things we've already learned, so you can go through it. Like most of the things we just want to see like how much you can solve using the concept learned in this particular course. So that's our aim right now, just going through the questions. Then for
Yeah, it is
11,
m minus k plus 1, n minus l plus
yes,
1. That it
we
is.
can check it out. Let's put it. So yeah, basically minus one, like it will like reduce that dimension and then adding one. It is correct answer.
But it is not involving padding and all.
Yes, not. We have not considered those things. And it is also not specified in the question as well. Then for 11-bit pixel radiometric resolution, what will be the number of cells in the histograms? And
2048.
yeah, so 2 to the power 11. The scatter plot is used for,
Understanding the correlation between
yeah,
values of one channel and values of.
exactly. Given a real variance covariance matrix, which of the following is true? So if you have variance covariance matrix, which we also did, its eigenvalues can be both positive, negative. That's true. Eigenvectors are mutually orthogonal, so that is also true. Its size depends on both image size and number of bands. No, it's not. It's always non-singular, not true. Then which of the following sampling algorithm retains the raw pixel values from the original image? So nearest neighbor. So few questions are repeating here. The Gaussian Laplacian of Gaussian filters is applied for which kind of filtering? So I think this is a bit advanced. Then we have the minimum maximum radiance value generally provided in the image header file is used for contrast stretching. Generally we use it.
I think 8 is C.
8 is C, zero crossing. I'm not into that domain, so I don't know. Might be correct. I don't know. Uh, then we have unsupervised classification does not require prior knowledge of the region. Because it's true. Uh, so this is true. Like it does not require any prior knowledge of the region. You just give the image, it will classify. Which of the following is not a measure of separability? So this is also think we have not gone into this one. Then calculate the percentage of total variance in the data explained by each principal component. It's calculated from the Bayesian data. So this is also we have to find the variance using the eigenvalue. So we have not gone into detail about this PCA. So you just go through it, how to do this. Then convert the RGB multispectral dataset into HIS. So there is a standard relationship between to convert from hue intensity in this saturation using these values. So there are like standard formulas for that. Then NDVI already near infrared minus red, near infrared plus red. So option correct here will be the C one, this one. The intensity hue and saturation system. So it's like just go through it. Identify the low pass filter. So here if we see the first one is
C.
I think high pass. This is I think C is a low pass filter.
No,
D,
D is high pass.
and D, there is a like high value in the center.
Yeah, so D is high pass.
Okay,
C.
yeah. True, true. So this will like suppress the low and this will pass it. Okay. Um, the range of minimum and maximum. These are like further similar like repetitive questions. Image
These
segmentation.
questions really repeat in the same question paper.
Yeah. It's like when this subject got offered for the first time, they have given it as a you might expect this kind of questions in this subject.
Okay,
So that
okay.
is like
Model.
when this model paper was offered in the 2022, it's like you might expect this kind of questions in the exam. So that's why like most of the questions are repeating itself. It's not like
But
it's
this
a
is a very tough paper, huh?
like
All papers are, I mean,
yeah,
papers
this is
are
like
like,
they are
no.
suggesting you might expect this kind of things. So then based on that they have delivered like other like all the papers are like very less difficulty compared to this model paper. So this is like region growing. So it's like for this technique we use when we do the classification to identify the pixels, like
What?
case of unsupervised classification and all. It's not a watershed. It's a process that groups the pixels or subregions into larger regions. Yes.
Huh.
So like these are the questions like, but you now know like more than 80% thing like you can do it after going through this course basically just from this course, not anything else. Like around 70 to 80% things you can solve basically using the no like concepts which you learned during this advanced geomatics engineering course from NPTEL. So I like really suggest to go through this course again, like videos and all. This will help you to give your NPTEL exam as well, along with that GATE examination as well. Go through the videos which we solved. You can directly go through the GATE's question paper if you don't want to go through like question wise or like topic wise what we did in the lectures. So you can directly go through the papers as well. And what else is remaining? I think we have covered most of it. Uh, now, I think I can give you some glance on some of the questions paper, like or kind of analysis which we are doing at IIT Gandhinagar. So we are having one course on geospatial engineering here. In the course, we use the normal GIS operations, surveying, and those things. And then we have some exams on that. Like, so what we gave in this year's exam paper, this I just want to share with you. So here, I mean, what kind of questions we can solve using the GIS? I'll just present my screen. So I think so. This is the questions which we have given to the students. What they have to do is like the need of discussing this thing is like we have also learned through the same concepts in our course on GIS. GIS part basically last 2-3 weeks and some of the hands-on sessions which we have carried out. So if you have these questions or this kind of problem statement, how will you tackle the questions? Basically, that's what I want to understand from you. So we have the first questions, or this entire question paper is based on the data sets from Bangalore. So different data related to the lakes, parks, schools, then built up like land uses, and then some environmental clearance, and then they have to give the decisions based on the data. So Balandur Lake, which is one of the largest water body in the Bangalore, plays a critical role in the city's water ecosystem. However, we like also know that lakes from this Bangalore are disappearing because of the urban encroachment which is happening there. And in response to that, what we have to do is we have to do the hydrological analysis of that particular city. So the questions which we ask, like we have to show the map of river, and the data given here is the data layer of elevation. So I will show you the simple data as well. So,
So, what the paper you have shown is a practical exam or the written
yeah,
one?
it's a practical exam. So they have, people have to use QGIS to solve the analysis. Just let me connect with the folder. So if you are interested in doing it, we can share this data with you. So we have given this kind of data set. So this data is, I can open the main. So what we gave to our student is like we have given them the digital elevation model, and all of you know that like a digital elevation model will like show the elevation like this. So we have given this data first of all of Bengaluru, and what they have to do is, they have to come up with the catchment area. So how much area can contribute to the water at this particular lake, which is Belendur Lake. So first of all, what we have to do to solve this question is we have to find out the location of Belendur Lake, that where this Belendur Lake is located. So for that, we can use the data layer of let's say different lakes like this, and from that we can find out the which lake is a Belendur Lake. So we can just write down, do the right click, go to the attribute table, and we can check the name of the lakes, that which lake is having the name of Belendur. So we can just find out, or we can do the this filtering options as well, and we can find out the name of that lake. So here you can see some of the are null, and you can see this is the Belendur Lake, which you can see here. So we can select those things, and we can see it's over here. So now what we want to see is how much area is draining water at this location. If you see within the Google images or is like satellite map, so you can see this lake is situated over here, and then this is the entire Bengaluru, and then we want to see like how much water it is connecting from the various parts of the Bengaluru, and the lakes which are there in the Bengaluru, whether they are connected with each other or not. So for that, we can do the standard watershed delineation process, which we have learned in our course also. And we can generate the catchment like this, like which will show us the that how much river. So this thing, it is known as a watershed delineation that we have learned in this course. We can generate the, we can use the field sinks, and then we provide the flow direction, flow accumulation, and then catch like upslope area determination, and then converting that image into raster to vector, and we will come up with this kind of things, which will give us the catchment area. So this much area is responsible for the water in this lake. So now if the river is drying, like or this lake is drying, we have to focus on this area, that what is happening in this area. If lots of urbanization is happening, then what will happen that if what will happen to the water if urbanization will happen, then one thing it can be that urbanization will directly drain water to the channels, because now water cannot filtrate into the ground, and it will like reduce the groundwater, but it will like directly follow this path, and it will like make this lake full. However, what if urbanization is happening near to these lakes? If urbanization happening near to these lakes, this lakes area will decrease basically, and because of that, now water is coming to like this catchment. We are like urbanizing it, so more water will come compared to the previous years. And now we have constructed the homes near to this particular lake by doing this like FZ development. So these regions will be highly prone to flooding. And that's why in the follow-on question, what we have done is we have given the land use data to the students, land use data from 2015 and 2019. And we asked the student that how much urbanization happened in this particular catchment, which is responsible like for this various hydrological processes. So they have to quantify the urbanization change which happened in this particular catchment. And then once we done with the analysis like how much urbanization happened, then on surface what is happening that we can see, but what is happening at the below like in groundwater that we can't see. So what we have given is we have given the groundwater data to the students. So we have given the data like this, which is representing the groundwater level depth in particular year. And we ask the student to prepare regions which are like severe or which are having higher groundwater depth, or the regions which are having the lower groundwater depth, so from where we can find out the groundwater easily. So they have to find out the potential zones, or using this data we can find out the regions where we can do the water like groundwater recharge using the rainwater harvesting and so on and so forth. So further, how we can utilize this thing is we can generate use the interpolation tools. And after using the interpolation tools, what we can do is we can generate a raster data of this particular depth. So once you will do this thing, so it will generate a raster layer like this, and it will give us the which region has groundwater at above, like near to the surface, or which has the more depth, where we have to dug more if we want to get the groundwater. So this like integrated questions, like how you can solve the to find out the water stress which is happening in which region and which is because of which parameter. You can also integrate the further data related to the pipelines and water supply which is happening at this locations, and do the more analysis finding out the which regions are going to express the like experience the stress in the water supply or the other thing. You can also include the data from rainfall or as well. So that was like in the first questions. Then the few questions, let's say we have given them one project site, which is environmental clearance basically. So if you see any kind of environmental clearance, so there is a page on GitHub which has digitized all the environmental approvals from the government portals, and they have given the CSV file for all the approvals. So for different like this file is big, we can download. So there is a portal named as Parivesh. I mean, if you see in this portal, what like if I want to construct anything, let's say residential building or commercial building, I have to take the environmental clearance from the government. And in that, what they will do, they will mark the digital boundary of the project, and then they will analyze the nearby properties, how they are going to affect to the ecology in the region, how they are going to affect in the wildlife in the region. So everything we have to do, and then data set that how much is going to affect is given in this particular Parivesh portal for each and every project. So you have to get the environmental clearance from the project like authority, and we'll see if we are able to see some data from this portal. So you can see this data sets. So on that GitHub page, I think Search the question. So the data which we have given is like from actual projects which is being going to executed. So you can see this kind of files which is like showing the actual detail about the projects. And then let me see this. Just give me a minute. Just give me a minute. This is very high amount of data. It might think if your system is not good, it might crash. So, I mean, every construction project has its proposal number, then the date at which they applied, like date and time, then the name of the project which they are going to do, then it comes under which of the like description about that project, whether it's like a renovation or like this, they are doing the addition into the already existing building, or they are doing the entirely new project, and so on and so forth. Then state, district, total cost, how much employment it will generate during the construction, then an operational, how much employment it's generating, then project land requirement, how much it's requiring, then organization which is doing that project, then project category, and then proposal URL. So if you go just copy paste this proposal on internet, so you can see the that particular project, and then if you go down, it has entire detail like which topographic sheet is coinciding with this particular project, then KML file if it is they have uploaded. So every project has to upload it their GIS ready file. So you can see this, they will like have this kind of KML file which you also can download, and then what you can do is you can just see this file in GIS, something like that. So basically this file is like this, and then if we provide the, so this project which we see, it's going to come over here in this particular region which is like bare, and they initialize this work. Okay, they have put like for government approvals. So now here you can see this project is going to be constructed over here in near to some wildlife, or if some forest area is there. So how much clearance is required to carry out the project? So all those information. Now why they have to give this kind of KML files? So if forest people are there, they will use directly this KML file, and they will intersect this area with the their forest map. They will intersect if the any new road are coming up, then they will put that KML file of road in the with the file of forest file, and they will say like how much road is coming under the forest area or from the ecological sensitive region. So they will do all those kind of environmental analysis using those this particular thing, and then they will consider that land requirement of the project or activity. So whether that land is natural land or non-forest land or forest land, so they will calculate those numbers, and based on that they will take the permissions from the corresponding authorities. So this is like things, if you are interested you can go through it, and then you can analyze the different upcoming projects. You can just, this data set is there, so how you can analyze it's on you. But this thing, very good amount of data is there for executing such task. And our question is in that line only, that if any construction project is coming to the Bengaluru, and then some company wants to like start their office which is focusing students. The product is focusing student or child care sector. So what we have to do is we have to find out how many schools are there within the 5 kilometer radius of the given upcoming project. So we can do the tools like buffer analysis, and we can find out that how many schools are there nearby, or if they want to advertise their particular brand in nearby parks or playgrounds where the different people like are there who are having childrens. So we will construct the buffers around those things. So we have given the data related to the, so this is the project site which is going to come up at the location. So you can see here. So this is the site, like this is the blank area is there, which is going to come up with the site, this one. And then how much schools are there in nearby region. So what we have done, we have taken the buffer of 5 kilometer, and then we have put the data related to the schools, parks, and other thing, and then we have taken like did the filtering and the extraction tools which we learned in the hands-on session, and then we found out how much schools are there, how much parks are there, how much playgrounds are there. And then further questions are related to the network analysis. Let's say if we have network of roads, then how we can find out the optimal route between the metro station and given hospital, metro station and given restaurants. So if you want to use the connectivity from metro, whether it's good, if you want to go from one location to another location, how much we have to walk apart from the metro. So those kind of analysis also you can carry out in GIS, and this is just examples how you can solve the different questions. So I request you, I mean, like to along with the other things, you should also use this GIS tool for solving the real life questions. There are different websites like OpenCity Data, which you can use to download the data sets of metropolitan cities like Ahmedabad, Bangalore, Delhi, and some other cities also like Kolkata, and some uh, like so many data are there. You can find the data sets on Kaggle site as well. So you can use those sites and find out the different data and then do the analysis. So with this, we will end this class as well as this course. So thank you for joining for this long classes on Monday evening. And I like to acknowledge all of you who joined and attended this class. Hope you learned from this class, and this will be helpful to you in your professional life as well as in teaching career as well if you are doing, if you are a student in your syllabus as well as in the examination like GATE. Yeah, thank you everyone.
Hello,
Any,
sir, excuse me.
yeah,
So I can get your mobile number, sir?
you can connect with me LinkedIn. We'll discuss everything there.
Okay, 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 okay. Okay, okay,
Thank you,
sir.
Hiren. Thank you so
Yeah.
much for giving us all of the additional information that was included and also not included in the syllabus of the course. It has helped me. Wishing you all the best in your career, and hopefully your teaching is going to help me in mine. Thank you so much for getting involved and taking so much efforts.
So thank you everyone for joining because it's if no one is there, it's like kind of very difficult to conduct the classes. But you guys have joined throughout the end of this class, and it's very good for me. So thank you. With this, I just if you want to be in touch with me, please connect with me through my LinkedIn profile, Instagram profile, or Twitter profile. We'll discuss some ideas there as well as if you are coming to Gandhinagar, please visit IIT Gandhinagar, our lab, water and climate lab. We are doing so much work in the sector of water and climate. You will know what we are doing, and if you will come there, we'll explain you what we are doing and how we are solving the real life problems related to the climate change in the sector of water, agriculture, and the other domains. So with this, I just close this class as well as this course, and see you. If I will offer any other class, you will get the notification through my LinkedIn and other things. Thank you everyone. See you. Good night.
Thank
Thank you.
you.
Bye.
Thank you.
Good night.
Good night, Hiren. Bye bye. Bye. Thank you so much. Bye.
Bye.